All right, so this question, all right, let me increase this size because I don't think you can see properly. So, right, follow table gives a probability distribution for the number of textbooks sold on a given day at a bookstore. And so textbooks sold, that would be your random variable x. And we see that x can take on values from 0 to 6, discrete random variables, so only whole numbers. And then you see the probability related with each of those numbers x can take on. So we can set up our probability distribution with the values for x, and then probability of x. We have those given as 0.05, 0.12, 0.19, 0.30, 0.20, and 0.110, 0.04. Now, we said that in order to be a probability distribution, each of the individual probabilities needs to be between 0 and 1, and the sum of all the probabilities needs to be equal to 1. So let's see if we have.
Excuse me, miss.
Sure.
Under the probability tree, it says 30, or I'm not seeing correct.
Yeah, you're probably not seeing the decimal just in front. Um,
Okay.
Let me just. Do you see it now? To make this. That's not changing, but yeah, there's a. This is written without the zero in front of all of them, but there's a decimal point in front of all of them. And so the mean, I'm getting a sound that I don't know if it's somebody's mic. It seems to be coming from my system. It's weird. All right, just make sure it doesn't break down. So it's really just the sum. Okay. So it's the sum of x times the probability of x. And so that means that we need to find the sum of x times the probability of x, which means that we will have to, we have x and we have the probability of x. So all we need to do is multiply the two sets of values and take the sum. So as we would expect, anything times 0 will give us 0, and anything times 1 will give us that same value. And now we have 2 times 0.19 will give us 0.38, and then we have 3 times 0.3, which will give us 0.9, and then 4 times 0.2, which will give us 0.8, 5 times 0.1, which will give us 0.5, and then 6 times 0.04, which will give us 0.24. So we want to then add these values. And so we have our mean or expected value. The mean is sometimes referred to as the expected value, so you would also see expected value of x is equal to 2.94. And of course, it's referred to as the expected value because if you were to repeat this experiment over and over, it is expected that this is the value you are going to, on average, this is the value you are going to arrive at. And then now, so you're clear on how to find the mean for the discrete random variable?
Yeah.
Great. And now the standard deviation, this is a much shorter route than we did when we did the standard deviation, for instance, for group data. It is the square root, and I name my symbols tonight. Square root of the sum of x squared. I'm just writing this out in words so that that's how the formula means. So it's the square root of the sum of x squared minus the mean squared. So we already have the mean. We will have to square that value. And then we have to find this expression, which is the sum of x squared. So the mean of 2.94, this is looking at the standard, the distribution for the number of textbooks sold on a given day. And so a mean of 2.94 means that typically the bookshop sells on average of 3 books a day. It's a discrete variable, so you can sell 2.94 books. You will round that up to the closest whole number, so it means the bookshop sells an average of about 3 books every day. And right, not surprising because you see that the value 3 has the highest probability attached to it, and so that sort of makes sense, right? So you can also, when you calculate your mean, you just go back to your data to see if it actually adds up. And if it does, you will include that in your explanation. If it does not, again, you will also include that in your explanation, because sometimes the data sort of the calculation sort of supports, and then sometimes you will find anomalies. And so those are also important. And so for our standard deviation formula, we are going to first have to square the x's. So you're going to have x squared, and then it's going to be x squared times the probability of x. Times probability of x. So again, 2-step process. We could go 1 step, but we want to minimize errors. And so we're going to go 2 steps. So we first square the x's, and then we do x squared times the probability of x. Let's just write that. Right. Good. So we have our x's. Remember, our x's are in the first column. We just center these so that's and bold. Right. So remember, x's are in the first column, and that's what we want to square. So we know that 0 times 0, we expect that to give us back 0. And then 1 times 1, we also expect that to give us back 1. 2 times 2, I mean, these are small numbers, so we sort of know what to expect when we square them, but again, we're trying to minimize error. And so we're just going to go through the long process of doing it individually rather than dragging and dropping the formula. Are you hearing me clearly? Because I keep getting a feedback on this. I'm not sure if the audio is coming up here.
We're hearing you clearly.
Okay, great. Thanks. Right. So now that we've squared the x's, we now have to take x squared times the probability of x, because we need the sum of this column for our standard deviation formula. So it's going to be now x squared times the probability of x. And by now you'd figure out that everything in your first column, in that first row, is going to work out to 0, because x is the first value of x is 0. And everything in the second row is going to work out to be the same value as the probability of x. probability of x is equal to 1, because again, anything times 1 will give you back the same value. And so now for x squared for 2, we have 4 times probability x is equal to 2, which is 0.19. And then we have x squared here is 9 times the probability x is equal to 3, that's 0.3. And then for 4, you have 16 times the probability that x is equal to 4, which is 0.2. And then here, square 5, you get 25 times probability x is equal to 5, 0.1. And then 36 for the square of 6 times the probability that x is equal to 6, we get that value. And so we want the sum of this column. That gives us 10.72. And so you'll get a bigger value, but remember we have to, this is squared, everything is in squared units here. We will have to square root that to get a standard deviation. And so we see our formula for the standard deviation. It's a square root, but this time we know what's the sum of x squared. I didn't write everything I needed to write here. So it's the sum of x squared times probability of x times probability of x. Right, that's a complete formula. Now we know what is the value for the sum of x squared times the probability of x, and that is 10.72. And then we also know what is the mean. The mean is 2.94. So it's going to be 2.94 squared. That's either where you go next, right? And so we have never mind. Right, so we're gonna put back our square roots because we need to do that. And then we have 10.72, we'll leave that there. And then we need to square the 2.94. It's gonna be 2.94 times 2.94, and that gives you 8.6436. So now we have to minus, because when the formula says to minus. So it's going to be that minus that value, which gives us 2.0764, and now we have to square root this value. This is 1.44. So again, remember the rules regarding standard deviation will remain the same in that you can't get, so you're not going to get a negative value for a standard deviation. And so you will just be mindful of that again as well when doing the calculations for this. So the mean for the discrete random variable is the sum of x times the probability of x. The standard deviation is the sum of x squared times the probability of x minus the mean squared. And to find the sum of x squared times the probability of x, we will first square all the x's and then multiply those squared values by the probability of x. Once we get, and then we take the sum of that column. This is the sum of x squared times the probability of x. And once we get this sum, then we put it into the formula. So it's going to be the sum of x squared times probability of x minus the square of the mean. So you have that value, you square the mean, then you minus the two values, and then you take the square root. So you always work out the square of the mean first, then you minus, and then you take the square root. Do you have any questions? Do you understand what happened? You think so? Okay, great. All right.
Yes, miss, everything was clear.